Brianna, Susie, Tiffany, and Rebecca are enjoying a wonderful day at the beach when they realize that their parking meter is about to expire. They are 300 feet from the pavement, and that point on the pavement is 500 feet from the car. On the sand, they can run 3 feet per second, and on the pavement, they can run 7 feet per second. What is the distance they should run on sand and pavement to minimize the time it takes to get to their car?
So by the Pythagorean theorem, we're able to find out what the sand distance is equal to. The sand distance equals the square root of x squared plus 300 squared. And the concrete distance equals 500 minus x. We can run on the sand for 3 feet per second, or on the concrete 7 feet per second.
Therefore, by multiplying the rates by the distances, we get the equation total time is equal to 1/3 times the square root of x squared plus 300 squared plus 1/7 times 500 minus x.
By deriving both sides of the equation, we get dt over dx equals 1/3 times 1/2 times x squared plus 300 squared to the negative 1/2 power times 2x minus 1/7. Let's now simplify.
To find the minimal distance, dt over dx must be equal to 0 if and only if x over 3 parentheses x squared plus 300 squared to negative 1/2 is equal to 1/7.
Next, you multiply by the reciprocal and end up with 3 times the quantity of x squared plus 300 squared to the 1/2 power is equal to 7x. Then, to eliminate the 1/2 exponent, you multiply both sides by the squared and end up with 9 times the square root of, or 9 times the quantity of x squared plus 300 squared is equal to 49x squared.
Distribute the 9 and solve for x.
Now, with the x value we found, we will plug it in back to the first equation where sand equals root of x squared plus 300 squared and solve for the minimal distance. Sorry. On sand, we should run approximately 332 feet. Now, referring back to the top portion of the problem, we must find the distance we must run on concrete using the formula 500 minus x. Now, the distance we should run on concrete is approximately 357.7 feet.
To find the total time it takes for us to get back to our car, we divide the sand distance by the rate, which is 3 feet per second, and add that to the concrete distance divided by the rate, which is 7 feet per second. It takes approximately 161.8 seconds for us to get back to our car.
Now we must check our endpoints to make sure we're going the most time-efficient route. So by the Pythagorean theorem, we can find that this distance is 583.1 feet. And because the distance on the sand was 3 feet per second, we divide our 583.1 by 3. And we get 194.36 seconds.
Now, we must also check the alternative route of walking 300 feet on the sand and 500 feet on the pavement. And we will multiply these distances by their respective rates. This gives us a time of approximately 171.4 seconds. In conclusion, we can tell that the minimal path does give us the quickest time to get back to our car, which is 161.8 seconds, opposing the all sand path or walking on sand and pavement.